Apply directly the definition of slope of a curve in order to calculate slopes. Find the equations of the tangent and normal line to a curve at a given point, and find the average rate of change of a function. So average rates of change, the average rate of change of a quantity over a period of time is the amount of change divided by the time it takes. Distance equals rate times time. We talked about this before. In general, the average rate of change of a function over an interval is the amount of change divided by the length of the interval. Also, the average rate of change can be thought of as the slope of a secant line to a curve. So this is more likely what we're going to be doing is that, we'll have this curve and they'll go this point, and you'll calculate the slope of the secant line. Now keep in mind in calculus, what we want to do is take this curve here and move him down so that we get a tangent line. But we'll work there. We'll work our way there. So the very first one, average rate of change, find the average rate of change of f of x equals 2x squared minus 3x plus 7 over the interval of -2 to 4. So you're simply doing f of 4 minus f of -2 all over 4 minus -2. So this gives us 2 times 4 squared minus 3 times 4 plus 7 minus, please don't forget to put the second guy in parentheses, 2 times -2 squared minus 3 times -2 plus 7 all over 4 plus 2. So 4 squared is 16 times 2 gives me 32 minus 12 plus 7 minus 2 squared is 4, 4 times 2 is 8, plus 2 times 3 is 6, plus 7, all over 6. 32 minus 12, 20, plus 7, 27. And 8 plus 6 is 14, plus 7 more is 21. So you get 6 over 6, or you get the average rate of change, to be 1. So that's what we got on this one. And we're just using our slope formula. Okay, let's try another one. On the interval from 1 to 3, so f of 3 minus f of 1 all over 3 minus 1 would give us 3 cubed minus 3 minus 1 cubed minus 1 over 3 minus 1, which is 2. This gives us 27 minus 3 minus 1 minus 1 all over 2. This gives us 27 minus 3, which is 24. This is 0, so just 24 over 2, or 12. So the average rate of change on that one from 1 to 3 is 12. Okay, tangent to a curve. In calculus, we often want to define the rate at which the value of a function y equals fx is changing with respect to x at any particular value, x equals a, to the slope of the tangent to the curve, y equals f of x at x equals a. The problem? We only have 1 point, and our usual definition of slope requires 2. So we're going to go back to what we had done, I believe, in section 2.1, where we kind of played with lines. So this one here is saying the slope of the curve find the slope of the curve and the equation of the tangent line, then draw a graph of the curve and tangent line in the same view and window. I have that here. So, but remember before we had a -1, we would just get closer to it. So, like -1.001 kind of thing. We just got close to 1 as we could. So we got to identify 2 things. Now on your paper, I know it says, oh, to do this process, no. We're so not going to follow that because it's going to confuse you more than help you. We're just going to go back to what we were doing in section 1. If my first x value is equal to -1, then my second x value is going to be very, very close to it, so -1.001. Now, keep in mind here, we have to write the equation on the line. They only gave us an x value. So if x equals -1, then our y value, plug in -1, 1 squared is 1, 1 plus 2 is going to give us 3. So we have, that way when we write the equation on our line, we're set, we're ready to go. So on this one here, we're going to do the f of -1 minus f of -1.001 all over -1 minus -1.001. So if we put this into a calculator, we're going to get 3 minus 3.002001 over 0.001, because this is going to become positive here, 2 negatives, positive. So in the end, we get a 0.002001 negative over 0.001. Yes, we're still using a calculator, which is going to give us a negative 2.001 or -2. So I don't want you guys looking at this going up. We're just using numbers very, very close to each other because it's going to be a very small change in the slopes. So we get a slope of -2. Now we're ready to write our equation of our tangent line. So don't forget, this is where we do the y equals, nope, I lied. Ooh, I didn't want to do that. Really didn't want to do that. Okay, let me hit my eraser. That's what I wanted. I didn't want the equal sign. This is y minus y1. I only have one y point, that's 3, equals my slope of -2 times x minus my y value, which is -1. There's the equation of our line. Here's what they were looking for. Please, please, please get in the habit of this. Leave it like this. Don't go beyond that. Okay, and there we have it. Our curve, y equals x squared plus 2, and our, okay, so they extended this, but guess what? -2, there's a slope. If I put -2 here, I get -2, and I add 3, I'm going to get a +1. So we know we got the same slope. But there's our equation. Okay, let's try this one again. So this one, my x1 is going to be 2. So my second x is going to be very, very close. We'll use 2.001. Now, if x equals 2, our y value is going to be 2 squared, or 4. Just plugging it in. So on this one, we get f of 2 minus f of 2.001 over 2 minus 2.001. This gives me a value of 4 minus 4.004001 over 0.001. Yes, I'm just throwing this in the calculator. Subtract this and we get negative, oops, by the way, that should be negative 0.004001 over -0.001, which gives me a value of 4.001, or 4. There's my slope. So we do y minus 4 equals my slope, 4 times x minus my x value of 2. And they want you to graph it. And there you guys can see there's the equation and then there's a graph. You can put this on the calculator as well. That way you can see what's going on. I know it looks like it runs along it for quite some time, but it is actually only touching it at exactly 1 point. Okay, so this is where we're going to stop in day 1 and day 1. And you can get started on the homework. Good luck.